Okay, so let's keep going. If I am not wrong, we stop it right here, okay? Anyone has any question up to now? Or we just keep going and we'll see later? Okay, so I mentioned right before going to lunch that there are two more transition mechanisms. The first one is called map encapsulation. Map encapsulation is somehow a stateless version of DSLite. All the mechanisms that we talked before in the last, let's say, 30 minutes before going lunch, like NAT64, 464, XLAT, have some state. Carrier grey NAT, all them, DSLite, all them have some state. Sometimes more, sometimes less. The state is kept in different parts of the network. So for example, when you have carrier grey NAT, the state is kept in the carrier grey NAT, the NAT64 keeps the state, the CLAT is stateless. So there are different variations, okay? So this protocol is a kind of way of doing almost the same as DSLite, but trying to get rid of the state. It has two elements. It has what we call the map customer equipment, the CE, and instead of the carrier grey NAT, we call it border relay, map border relay. Okay? This will be the diagram. As you can see, all the diagrams are almost the same. So you print them and you put one next to the other, you will see very easily the differences between all of them. Okay? You will see how many levels of NAT and so on. Okay? Where the public addresses are and all these kind of things. So, in the case of MAP-E, the E stands for encapsulation. Okay? So, what happens here is that we have, ground key here. We have one NAT44 level, only one, which is the same that we have today in our home or business CPEs in the CPE, okay, in the customer edge or customer premises equipment. So that don't change. And again, we have the public IPv4 addresses in the border relay, same as we had them before in the NAT64 on the carrier grey NAT. And then again, the IPv6 traffic goes untouched from end to end. Okay, so we don't do any translation on the IPv6 traffic or any encapsulation or anything like that. However, we have here the same situation as DSLite. We have IPv6 only access. You don't need any more IPv4 addresses in your access network. You could have your core network IPv6 only perfectly. Sometimes you don't do that because it was already deployed, so you don't change that. Or because you need to provide real dual stack to business customers, for example. Okay, so you keep the core network as dual stack. But the access network for residential customers or for those business customers that only need bandwidth, they don't need to export services outside, you can do IPv6 only. And this is the same for all the mechanisms except for NAT444, okay? And then what we do is we tunnel exactly the same as in the case of DSLite, we tunnel IPv4 in IPv6. What is the difference? In DSLite, you are giving every customer a number of ports, and that's kept in the state in the carrier grey NAT. Okay? While here, that mapping of these ports belong to this customer, these ports belong to another customers, are made with a rule, so it's automatic. And this mechanism is not a secret, was invented mainly by Cisco, And they have, I think I have on a slide, you will see later on that, they have a website where you put your prefix, you say how many ports you want for every customer, and it gives you a code to put in your Cisco router, and it gets configured. Okay? Of course, that means, and this is the reason I don't like this, that means that in addition to change the CE, and there are not many vendors that support MAP, that there are very, very few, your addressing plan is somehow made by the Cisco rule. Okay, so you don't really design all the addressing plan. You may design pop by pop, and then for your customers, that depends on the rule. Okay, I don't like that. I really prefer to make a very well think addressing plan and take my decisions, and sometimes not all the customers receive the same portion, or I want to have holes in the middle, or many, many things that this is not so much flexible, okay? And of course, you still have the limitation, as in the slide, and likewise for overseas, that you have to predefine how many ports you allocate for every customer, which is, in my opinion, a big disadvantage because applications are going to use more and more and more and more ports. And that means you will need to renumber your customers from time to time. Okay? And you will consume more IP addresses instead of having a dynamic thing like NAT64. It's a personal view, but it's based also in experience and trials that we have done. Okay? Now, if somebody wants to take a look later, I am not going to go step by step now, but you have here all the progress of the encapsulation of the IPv4 traffic in IPv6 Okay? There is a similar protocol which is called MAP-T, and the T stands for translation. It's the same concept as MAP-E, but in MAP-E we are encapsulating, and here we are translating. Okay? So MAP-E, it's kind of IPv4 in IPv6 plus something else to make the rule. Okay? While MAP-T is closer to what 464X-LAT is doing, but without the state. Okay? Disadvantage. Advantage, yes, you don't have a state. But disadvantage, you have to predefine how many ports you want per customer and make the rules according to that. So you need to take a decision. You want to have no restriction on number of ports per customer, and then you need, yes or yes, to have some state, or you want to have no state, but then you need to define a given number of ports per customer. That's the decision, basically. Depending on how you do that, if you depend on vendors, the cost is going probably to be the same. But instead of using vendors, if you use NAT64, you can make it very, very cheap with good and stable open source tools. Right before we started now, somebody was asking me our testing with Joule, which is a very nice open tool source for doing NAT64. It does a lot of additional things, but basically NAT64. We have tested that with 10-chip interface, and it was using, I don't remember, it was 1 or 2 4-core CPUs, but in any case, for the 10-chip, it was only using 25% of 1 core. So it's ridiculous, okay? It means really it scales to many, many gigs a single machine, and you probably will have 2 for high availability. And then the cost of having 2 good servers is for sure much lower than having a non-state board relay. Okay? So it makes sense. That could be the diagram. Again, it's very similar. But in this case, you have, because it's close to 464X lab, you have the NAT level 1, a NAT 46, a NAT 64, and then the public addresses in the border relay. Okay? I have a comparison table, I think it's the last slide. Later on, you will see how I am scoring all the transition mechanisms so you can also take a decision. It depends a lot on each network, but it's a good starting point to take a decision. So again, I have here the path for the MAP-T traffic and all the flow. If you want to compare MAP-E versus MAP-T, the difference is that in MAP-E, you have 20 bytes because the encapsulation of IPv4 of extra overhead. Okay? So that's the difference in terms of network overhead. It's not significant, but it's something to consider, of course. This is the web page I mentioned. I thought I have the link, but anyway, it's easy to find. If you look in Google for Cisco map rules, you will reach this web page, and then in the web page you put your prefix. You say, depending on the rules here, you say how many bits you want to use, how many ports per user, and it gives you, where is it? I don't see it now. It gives you, when you click here, it gives you a number, which you configure with that number of your router at each pop, and it's done. Okay? So it's very simple because they made it. But again, it's predefining number of ports per user, and depending on that, your addressing plan, at least at the pop level. Okay? If we compare DS Lite or Lightweight 4/6, you need to think that it's basically this figure. So we have a lot of tunnels from each subscriber to the carrier agreement. Okay? It means you have, depending on the number of subscribers, that number of tunnels, and then you have your BGP, your LGP, and so on. Okay, so you need to consider that view of a global network which DS Lite or 464X Lite. And the advantage of MAP is that because it creates this addressing plan for you, it's taking advantage of the aggregation, which with DS Lite you are not doing. You are taking, of course, advantage of the aggregation, which not 64 because you are aggregating only in IPv6, so that also makes sense. This is really all. I tried to get from Cisco a comparison with newer routers and newer protocols, but unfortunately they don't provide the figures. But with Cisco ASR 9K, DS Lite is routing the traffic in the ISM blade, and that means it takes 14 gigabits per slot, while MAP don't need that, and then it's taking 240 gigabits per slot. So that if you want to decide between DS Lite and MAP, probably you will go to MAP. Okay? But that's not considering if you put in the table 464X Lite. That's a different comparison. You can probably make yourself some testing if you have good performance machines, AGLENT or things like that. You can probably test by yourself. But usually it's something that not every ISP has the possibility to have that machine, or you can hire it for doing some testing and so on. At the end, it may depend also on how much you can spend in upgrading your network, what equipment you have, what vendors, what is their actual support, blah, blah, blah. Now, I did this table. It's not easy to see it from here, but you can study it later. And what I try to do is consider different kinds of transition mechanisms. I put 630 subwires, not 444, DS Lite, Lightweight, NAT64, 464X Lite, MAP-E, and MAP-T. Okay? And then I mention here if they are doing tunneling or translation. And then I look to different things like, I'm not going to read all of them, but for example, are they offering dual stack LAN? Do they support IPv4 multicast? How is the access network? Is IPv4 only, or is IPv6 only, or is dual stack? Do you need the CPE update? It's impacting in your addressing plan. How much is the overhead? And so on. Of course, this needs to be done depending on the characteristics of each network. So this is a very generic case. I am either talking about if there is support for IPv4 mesh, IPv6 mesh, IPv6 aggregation, sharing of IPv4 ports, so there are many, many things. And then the colors here are like the traffic lights, red, orange, or green. And this is somehow subjective, but considering a very common scenario, I am allocating half a point, 0 points, or 1 point. Okay, depending if it's half a point is orange, 0 points is red, 1 point is green. And then when you do this table, of course, 6RT is the winner. But you don't have any more IPv4 addresses. So it's useless. Okay? So that would be fantastic. But it's something that is not realistic in the long term. Maybe you are a small ISP and you are not growing too much, and you have already your IPv4 addresses, maybe. But you need to think in the long term, not just 6 months ahead. Okay? And then, from all the others, 464X-LAT, MAP-E, and MAP-T are very, very close. They are just half a point, one of each other. Okay? The winner is still 464X-LAT. You will say, okay, I don't want the state. Get rid of 464X-LAT. Go to MAP-E or MAP-T. But do you have a cellular network? If you have a cellular network, or at some point you may need to be, let's say, compatible with a cellular network, for example, for a backup link, the only protocol supported in cellular networks is this one. So then maybe you want to increase 1 or 2 points here. Okay? It's not anymore a matter of state, cost. It's a matter of, do you want to have 2 different transition mechanisms in your network? I guess not. It gets really messy. Okay? So I will not go that way. I mentioned this morning the question of how many ports per user. I took this picture from a guy in NTT, I think it's Shin Miyakawa. He made some testing showing that even Google Maps, when you start reducing the number of ports, and the testing was done going below 300 ports, having a single user behind a netbox, usually behind a netbox you have a family or a small office, so it's not just one user, and maybe they open several browsers, not just one, then instead of getting the full map, you start getting these empty squares. That's what happens when you are short in the number of ports, depending on the user applications. Okay? So that's a consideration. One thing I didn't mention, well, I mentioned somehow, is that the big problem we usually found when we want to deploy IPv6 is the CPE. Most of the CPEs today, at least if you buy in the market, don't have good transition mechanisms. So if you don't have the control of the CPE, that may be a problem. But if you can update the CPE, or you have a good agreement with the vendor, or you are a Linux fan and don't care to use OpenWRT, then it's not a problem. I am working in an update of the ITF document, which is the RFC 7084, to make sure that we support the new transition mechanisms like MAP, 464X-LAT, and so on, because those mechanisms are so new that in the original specifications for the IPv6 CPE are not included. Okay, so this is ongoing work, and I hope we can get, before end of this year, approved by the ATM. That helps to get the vendors having that support. Even in the case we don't get that, The base code for all these transition mechanisms is the same. So supporting, instead of just 6RD or DS Lite, supporting all of them, all those that we mentioned this morning, means maybe 100 Ks extra code, not a lot of code. And all that is open source. Okay, so it's available there. In the previous IPNIC meeting in Taiwan, I did a panel with CP vendors, and they confirmed this. That panel is recorded on video, so you may want to take a look. It was well-known vendors like NHC from Japan, Sitecell, which is well-known, and D-Link. So all of them said, yes, we have it. We just don't have it in the, let's say, general market. But if an ISP comes and say, hey, I want an update of firmware supporting this, we provide it for free, no extra cost. Okay? So they do on demand and it's done. And this will be the end of this presentation. Let me switch to the other one. Questions again up to here? No questions? Is this one? Yeah. Okay. Yeah. Take the mic.
Okay.
So the people outside can hear you.
Okay. Eddie Winston, IC. In general, what are the implications in terms of like speed and processing in using transition mechanisms versus doing native V6? I mean, I'm assuming to the user, they don't know, but do you have, what is your experience in that?
It's simple to answer. Same as the performance that you lose because the usage of IPv format, basically.
That's a great answer.
Yeah.
Okay.
I think that's because basically you are doing some kind of tunneling or encapsulation or both of them. It's more or less the same. There is no big difference. Of course, you can say if in a LAN we compare IPv4 with IPv6, IPv6 has extra 20 bytes, so it will take some extra delay, but it's not significant. I think some years ago we did that measurement, and IPv6 was at that time, before getting implemented in hardware, it was something like 3% slower than IPv4. But that was before this systems on chip have IPv6 support.
Okay.
Now I think it's no difference. Okay?
Okay. Thank you very much.
Okay. This you just push for a while. It says off. Yeah. So we don't burn the battery.
Yeah.
In this presentation, well, it could be faster than this morning, even if I said that the two slots are about the same size, but actually this is faster because I am going to avoid to repeat some of the things which obviously make sense here, right? So again, take your time to make your questions, and if not, at the end, we can try to see an overview of any of your networks and try to see what are the pros and cons that I can see, let's say, oversight of deploying IPv6 using one or the other transition mechanisms. Okay. I think this is clear. We don't need to explain that we run out of IPv4 anymore. Everybody should have an idea of that. If not, you should probably go to IPNIC so they explain you better. And sharing IPv4 addresses, in my opinion, as I explained this morning, is not the solution, and it's going to be more and more problematic. Okay? Remember that what I am going to talk here, even if it looks like cellular, it also applies to broadband. I will, at the end, make some consideration for broadband, but in general, it applies very well. We have more and more users, we have more devices per user, so it will mean we will need more addresses. The users are using in one device tethering to connect other devices, so this is obviously specific to to cellular networks, but it's the same concept as NAT in broadband networks. And there are many additional reasons for looking into the long-term strategy. Don't look into your IPv6 deployment as something for the next 6 months or 2 years. Look far beyond that. Don't make sense to go to 6RD or to dual stack, even if you have addresses now, but you will run out in 2 years. Because it means you will do the deployment twice. You will do dual stack now, and then IPv6 only later. Do you really want to invest twice, or you want to go straight? Okay? Another interesting thing, and there is a new IETF document, very recent, I think it's something like 3 or 4 months ago, is that, as you know, in IPv6, the rule was one LAN has 1/64, right? Everybody knows that. There is a new IETF way of allocating addresses, which is 1/64 for every device. Why? For example, a hotspot. I want to isolate customers. So if I give every customer a /64, they are isolated from the others automatically. Okay? Another reason. This is already happening in cellular phones. You give to every cellular phone a /64. So in case there is tethering, you can proxy the rest of the addresses, and you are actually using the cellular phone as a router. Okay? We can see several examples in an enterprise. You have one server, but it's running virtual machines. You want at least one IPv6 address for each virtual machine. So you want to allocate to each interface at every host 1/64. Okay? So this is one more reason for those that pretend to allocate to the customers 1/64. This is no sense. At least /56. My recommendation, go to /48. Okay? You also remember this picture, but now I put here the cellular phone and servers, because this is the situation we are going to see. We may have a dual stack cellular phone, but maybe the access is going to be IPv6 only, and that's already happening. Okay? I think there is the next talk after the break is precisely about the deployment using that, I think. Okay? So, do you agree the best solution is dual stack for the cellular phones? Yeah, we should agree. But do you have enough IPv4 addresses? Clearly not. And if you run a dual stack network, and again, this is valid for cellular networks and non-cellular networks, you are operating 2 stacks, so extra operation and management cost, call center impact because you don't know if the problem is in the IPv4 stack or in the IPv6 stack, in the access network, performance, battery cost, we mentioned this morning, sometimes depending on the scheme of licenses in the cellular networks, you may end up paying more licenses if you are running different dual stacks in different PDP contexts. We will talk about this later. Issues authenticating devices using 2 different addresses, that happens. There are software that get very confused if sometimes get an IPv6 address, sometimes an IPv4. So it thinks it's not the same user or the same device, but actually is it. So there are many implications that you usually don't realize. So what are the alternatives to dual stack? IPv6 only, that's one. We will see each of them in the next slides. IPv6 only with NAT64, IPv6 only with NAT64 and DNS64, 464 XLAT, or other transition technologies. Okay, so that's the different situations we're going to see now. IPv6 only. Well, we know that there are many content providers. The bigger example is probably Facebook. They don't have in the data centers any more IPv4 addresses. Maybe you are not aware of that, But Facebook got rid, starting in 2015, was already using 100% of their data centers with IPv6 only. And this is not, in terms of traffic, peanuts. We are talking at that time was more than 100 terabits per second. Okay, so more than 100 terabits per second of IPv6 only traffic in their data centers. How they still work if your customer has only IPv4? Because they do a kind of load balancing between the internal IPv6 and the external BGP session which is coming through IPv4. Okay, so there are different ways to do that, and in fact, Facebook tried different things. Okay, so at that time was using one, now is using a different one. So looking into this, if you provide IPv6 only to your customers, well, yeah, they can reach Facebook, they can reach Google, they can reach Cisco or Juniper because all of them have IPv6. But there are many sites or services in general that still are IPv4 only. So this is not really today a solution, right? It's not an option. So users, if you deploy IPv6 only, users will be able to access IPv6 only contents and applications, however, will not have access to IPv4 only ones, and if you have a cellular device that is offering tethering, and you have, for example, an old laptop that don't have IPv6 support, is an example. It's not realistic, but so you can see this. Or an old IP camera, and most of the IP cameras today are IPv4 only, unfortunately, or many kind of gadgets that we have at home are IPv4 only, and you will never get them upgraded because the vendor disappeared or broken or whatever. So you cannot offer tethering for those devices, okay? Because you have IPv6 only, IPv4 for them. So this is not a realistic solution today. Now, NAT64. I already explained this week about that. We are not going to invest the time here. Just one observation that was not in the slide this morning is how the NAT64 works. Well, basically there is a well-known prefix, which is 64 colon FF9B colon, and then you have the synthesis that I mentioned this morning of the A record. Okay, so this is how you reach an A record only site by means of an IPv6 prefix. Okay. I already mentioned this, something is not working with NAT64 and so on, and we have seen this diagram this morning. So it's exactly the same diagram, no difference. Remember that I had here the synthesis in the operating system of the device, okay? And today, this is how both iOS cellular phones from Apple and how Android cellular phones work. They can do, and even desktop operating systems like Windows 10, they can do the Quad A synthesis in the device itself. So yes, it works, but first, it's only valid if the device, if the cellular phone, if the user equipment, or the CPE, or the whatever device we're trying to get connected, has built-in Quad A synthesis, okay? So, for example, the macOS operating system today don't have it. iOS has it, but macOS not. And not all the Windows versions have it. Okay, so this is a difficulty. In the cellular world it's easier, in the non-cellular world it's not so easy. There is a couple of IETF documents. One is RFC 7050, which is the discovery of the IPv6 prefix used for the address synthesis, and the RFC 6052 which is the IPv6 addressing for the NAT64 translators, basically, okay, in short. For example, very recently has been accepted also in IETF a new version of Happy ABOS. You know what is Happy ABOS? Okay, let me explain. This morning I mentioned that we have a balance between IPv4 and IPv6 traffic, and the idea is that we give preference to IPv6 when a browser is trying to find a website, and only fallbacks to IPv4, so this balance can change if the IPv6 delay is to be compared with IPv4. The mechanism to take the decision of that fallback is called Happy ABOS. Okay? The Happy ABOS version 1 was invented about 5 years ago, and recently, after testing during 2 years, Apple designed Happy ABOS version 2. And Happy ABOS version 2 includes this address synthesis. So even if you have IPv6 only in an Apple cellular phone or a PDA, it will, well, any device running iOS, they will be able to reach also IPv4 only sites if there is a NAT64 in the provider network. Okay, so that works. Now, the rest of the cases, the users will only be able to access IPv6 only applications, like in the previous case. And again, tethered devices will not work. Okay? So that's, step by step, we are going to look all the possible options. Now, let's add this address synthesis in the operator network. This is called the DNS64. Okay? So the DNS64 is somewhere here in the operator network, and instead of doing the synthesis here, is done in the network. What that means? That the case I just mentioned, that a laptop from Apple will not work with the built-in synthesis because it don't have it, it will work here. The DNS64 will fake the response, and instead of providing an A record, will provide first a quad A record. Okay? So that means that the laptop will believe that that IPv4 only server is having IPv6 support, and then the NAT64 will do the translation. Okay? That works. I quickly described it this morning. How it works in detail, this scheme of NAT64 plus DNS64. Let's suppose we have an IPv6 browser looking for, this is the IPv6 browser, looking for an IPv4 only website. Okay? So what happens is that it will ask the DNS, which in this case is a DNS64, will ask for the record for www.example.com, and then the DNS64 will follow the chain until the actual DNS server, and then it will get a response, which, of course, because this IPv4 only is only an A record, the other side. Then it will fake it. You remember the prefix I just mentioned, 64:::, FF9B, and this is the conversion to hexadecimal of this one. Okay? And then, because this guy here believes this is IPv6, it will send the request to the NAT64, which will translate to IPv4, and again, the way back. Okay? So this is the way it works. Very simple, but you need to have either the synthesis here, oops, I am terrible with this pointer, or the DNS64 in the network. Now, Are we done? Is that sufficient? Well, we mentioned this morning, if the application is using literals, we are broken. Because the NAT64, the DNS64 will not be able to solve that. Okay? Or if the application is using the older socket IPIs, it will not work. If we have IP4 only tethered devices, will not work. And we have the same table we got this morning. Maybe it's not updated, but just looking for a couple of them is sufficient for not doing this. Okay, it's not a solution for our customers. So then we come back to the same conclusion we had this morning. Let's go for something a little bit better. 464XLAT. 464XLAT, and again, this is the same diagram basically, but we have here in the CPE or in the cellular phone itself, this will be broken. We have the CLAT support, and this will be a cellular phone case. Okay, it's the same, but one is for broadband, and this one is for the cellular phone. So in this case, the CLAT daemon here in the device is taking care, in case it's needed, of translating a stateless IPv4 to IPv6. So at the ISP network, we do the reverse translation. And again, the three scenarios we had this morning. Questions up to here. I went a little bit faster this time because most of it has been done this year, but now is the time to see if anything is missing. I know most of you are not cellular operators, according to the question I raised this morning, but instead of thinking in a cellular network, think in a broadband network. It's basically the same. There are a few differences, we will see them in the next slides, but it's basically very, very close. No questions? Okay, we have seen this morning as well. Sometimes I don't do bot presentations. This time they accepted me bot, so that's the reason I am repeating a little bit, but I think it's okay if I am going faster. Now, important thing here. You said you are from ISC, I got? You work with Mark Andrews?
Yes.
I am having a discussion with him about all these things.
Is it a nice discussion?
I don't know yet. Okay. What is the problem with DNS64? DNS64 is modifying the DNS answers, and of course, DNSSEC was designed to avoid such modifications. That's clear. So that means DNS64 can break DNSSEC. Okay? Actually, I will say it's breaking it always, but depending on how you validate, you will notice it or not. That will be the real way, the best way to say that. What happens is that, first, we don't have too much DNSSEC deployment, unfortunately. Second thing is, it's very strange that you have DNSSEC and you don't have IPv6. It's really strange. If you are deploying DNSSEC, probably you are an advanced guy, let's say, and you also have IPv6. So then you don't have a problem, because you don't need to use DNS64. You will get a response already from IPv6. You will get a real Quad-A record, right? I think it was Google, about 2 years ago, they did a study, and I think they are repeating it right now, or they announced that they will repeat it soon, and they said that only 1.7% of the DNS signed zones don't have IPv6. So the impact of this break is quite small. But in addition to that, the problem is that most of the devices today don't do validation. So if you at the end device are not doing validation, you will not notice this. if the DNS64 or the DNS validator is aware that there is a DNS64. And because typically in an ISP, you will have them either co-located or being the same box, that will not happen, okay? It's possible as well to do the validation at the CLAT. For example, it could be that the cellular phone itself doing the validation. Or if the cellular phone itself is doing the synthesis, then it's not breaking anything. Okay? So there are a lot of considerations. I have, I think it's about 10 or 12 pages of document in ITF, which I am trying to make a standard, explaining all this. So there is a very good description of all the possible cases. Okay, I'm not going here to spend on that because that's a 2 hours discussion at the minimum. There is another consideration. When I talk with the people that deploy cellular networks, which IPv6, they will tell me, and they have told that in public, in mailing lists, in Nano mailing list or in ITF mailing list, I don't care about breaking DNSSEC because cellular phones are not doing DNSSEC validation. That's true. They are right. But they are forgetting that tethering devices behind can do that. They forget that. Or they are forgetting that even if the operating system itself don't do the validation, it has the functions so developers of applications can call those functions to do validation. Okay, so that means they can get broken. So I really think if you deploy a cellular network or a broadband network without considering this, you are doing it wrong. The right way, in my opinion, is 464XLAT, but there are ways to do 464XLAT without the need to use DNS64. Okay? For example, you could force all the IPv4 traffic to go through the CLAT. Even if you translate twice every IPv4 packet, it's less harmful than doing the DNS64. That's a very simple way. Okay? Last possibility. Wow, I am really going too fast now. I think we are going to have 1 extra hour for discussion. Other transition technologies. Well, we discussed it this morning, 6RT, DSLive, MAP, etc., etc., etc. No way. There is no support at all in any cellular vendor for any other transition technology different than 464XLAT. That's it. No discussion. No way. You cannot do that. And that's why I was saying that even if you have both broadband and cellular network, it doesn't make sense. Even if you can get rid of a state in the non-cellular network using MAP, for example, it doesn't make sense to have a cellular network with 464XLAT and then have your broadband with MAP. Or maybe you want to have your broadband network with whatever technology, but you have an agreement with a third-party operator providing a backup link through 3G or 4G. And then you cannot use the same technology for that backup link. Is that useful? Is interesting? It gets you in a big trouble. While if you have the same technology for your main link and your backup link, you are done. It's easy. Okay? So those are the considerations that even if you don't have a cellular, but at some point you may need cooperation with cellular providers, Internet of Things, for example, this is something that you need to keep in mind. You really need to consider when taking the decision about how you do your IPv6 deployment. I think what is clear up to now for everybody, if somebody disagrees, raise your hand, and then we go fight outside. There is no way today it makes sense to deploy dual stack? That's first question. You will end up without IPv4 addresses sooner or later. There is no way to use transition mechanisms based on IPv4 for the same reason. So no reason to use 6RT, for example. Okay? So the last thing is, do you want to deploy IPv6 only, or IPv6 only with IPv4 as a service? And that's probably the answer today. Maybe in 3 years from now, you get rid of the IPv4 service, but you don't know when that happens, when that will happen, right? So you need to find the way into the long term, and that's definitively IPv6 only. But don't need to forget that today you need to provide in the customer lands some kind of IPv4 connectivity. Okay? Performance. Again, this is a little bit old. It's from 2015, but Facebook didn't public figures of this comparison since then. I think it remains the same, and let me explain each of the graphics. This is US service provider, it's public, it's T-Mobile. Facebook measurements using dual stack with Apple devices. Okay? This graphics is time of HTTP GET completion. So it's not meaning it's faster, but if you look from the user point of view, is how much faster I see that. Okay? Which at the end is what matters. How much is the response that the user gets in a web page? That's what really cares, right? So this is IPv4 and this is IPv6. IPv6 is 30% faster. 30% is a lot. We are not talking about 3%, it's 30%. That's a lot. Now, look at that for Android, 40%. Wow, Android is better than iOS. It was better at the start at some point. What Apple did is they used mobile precision in the Facebook app, in the application for Facebook. They included their own IPv6 stack. They were not using the Apple stack, and then they got the same performance, 40% as Android. Right? Probably Apple already sorted out that now, I am guessing. But that's an interesting observation, that an application developer says, Apple, what crap are you doing in your IPv6 stack? I don't think now it's happening anymore. Okay? That's really interesting. 40%, let's say, again, perceived performance from the user perspective is a lot. It's almost double. Okay? Akamai and other vendors and other providers, different kind of people, has done similar testing, and all is the same. And yes, this was on a cellular provider, but in broadband it's about the same. Okay? For example, this morning I mentioned the energy in terms of battery cost of the keep alive in the solar farms. But are we realizing the extra cost of energy because the NAT translations in every city in the world? If we could calculate how much energy that means, that's probably a lot. So all these small things, when you put them together, they care a lot, right? Cost. If you go to 464XNAT, in general, I already mentioned this morning, NAT64 scales much better than any other technology that, by the way, you cannot use in cellular because they are not supported. Okay? You don't need to buy typically IPv4 addresses, while in other technologies you buy. Because things like what I mentioned about PlayStation, you get IPv4 addresses banned, which is not happening today, at least, with NAT64. So, because you are making like 65,000 flows per each IP address, sharing it between all the users, at the end it means that you are scaling much better with less addresses. Okay? If this user is using only 100 ports, the rest of the ports are available for users, while in technologies like MAP, it's fixed. You have 2,000 ports or 1,000 ports for each user, even if they don't use them. Progressive deployment. With this, you can do at your own pace. So you can, for example, say, I am going to deploy IPv6 only for new cellular phones. So you are not impacting existing users, and you are somehow naturally increasing your IPv6 traffic. As more servers provide IPv6, and we know today YouTube, Facebook, Google, they are probably consuming 40–50% of our total bandwidth. Each one has his own measurements on that. So that means 50% of your traffic is already IPv6 when you start deploying that. And that means you drop the usage of IPv4, and that means you drop the usage of your NAT64 box. Okay? Billing. I had this question the other way. I don't know where it was. I think it was one of the tables during lunch or something. Somebody was telling me, people get scared of deploying IPv6, and this is not just a problem in cellular, but also in broadband, because the billing applications. Because the billing applications are using the 32-bit addresses or things like that. Okay, let's consider that. You have a billing application that has only 32-bit space for the customer. Okay, let's say that way. Now, from the 128 bits that you get for each IPv6 address, because you allocate to the customer prefixes, let's suppose you allocate to the customer /48, and you get from IPNIC /32. So you only need to take care of the 16 bits in the middle for each customer. That's it. You don't need to put the 128 bits on the billing records. You see the point? But even if you want to do that, you can do hashing, you can truncate addresses or whatever. But in fact, you can just use a portion of the prefix that is allocated to every customer. You don't need to use the complete address. Because if a customer gets /48 or /56, you don't care which computer is taking the traffic inside this network. You just care about which contract is doing this traffic, which customer, right? That's it. End of history. So this is a myth. People believe this is a problem. It's not. You can make a very simple proxy between your data gathering system and the billing application to make it happen. Okay? It's really simple. Roaming. I remember this morning I asked how many of you work in cellular, so I am not going to extend a lot in the next slides because I think only 1 or 2 people raised their hand. So I'm going to be a little bit fast here because there is a lot of terminology that if you are not used to cellular, you will get lost. Okay, so I am going to just mention very high-level things. One of the problems of cellular networks is the need for roaming support. So for IPv6 support, there is something called a policy and charging control function, which allows you to selectively enable IPv6 in the customer sessions when they are in roaming, depending on the roaming partner. So you can say, okay, when my customers are roaming into the France Telecom Orange network, let's enable IPv6. But when my customers are using the, I don't know, whatever network in Hungary, just to say, they still don't have IPv6 enabled, so don't allow roaming in that network. Okay? So that's something very, very easy. There is, In addition to that, if you want to learn more on that, there is a document from IETF, which is 7445, which is doing an analysis of the failure cases of roaming scenarios with IPv6. Okay, so there is a very complex document explaining all that. Overall, IPv6, 3G, 4G architecture. I'm not going to read all the names, but just to give you an idea with the picture, this is what we have. The user device, user equipment, the radio area network. Then we have the PS domain, IPv6 ISP. You can recognize here things like DNS64, NAT64 that we already mentioned. And then we have the connection to internet. Okay? That's, even if you don't know about cellular, you can see it as a regular network and don't pay too much attention to low boxes, SGSGN, GGSN, which are specific to cellular networks. Okay? What is important here is to understand that in cellular networks there is what we call the user plane and the transport plane. The transport plane can run on a different IP version than the user plane. And then we have the radio area network and core network transport that can also run on different IP versions. Okay? So when we transport user packets, we have what we call a PTP context, which can be of different types. You can understand a PTP context in a similar way as a PPP session. Okay? You can view almost as the same, no difference. So what happens is that the IP packets are tunneled through the cellular network, and there is an interchange of data that creates what we call the mobility management context. And then we have a PTP context activation, which is PTP stands for Packet Data Protocol, to make sure that all the characteristics like quality of service, routing information, IP addresses are provided to the end user device. Each subscriber may activate, and this is the key thing from this slide, several PTP contexts to the same or different GGSMs. Okay? And when activated to the same GGSM, they can use the same or different IP addresses. This looks like very complex, but here you can see it. You can have a terminal with multiple PTP contexts to the same or different GGSMs. And the important thing here is this the PTP context can be IPv4 only, which is called type IPv4, IPv6 only, which is called type IPv6, or dual stack, which is called type IPv4 v6. Okay? You have dual stack, which two PTP contexts, one for IPv4 and one with IPv6. But that means you are paying typically two licenses, because typically in the server providers you are paying licenses depending on the number of PTP contexts. Okay? So you have two links, one for IPv4, one for IPv6, you pay twice. So with 464X-LAT, you are using only one PTP context, which is IPv6 only. So you pay only once. Okay. I say this thing again, look for long-term strategy. It don't make sense you deploy now IPv4 and IPv6 in different or in a dual stack context if you are going to look for the long term with IPv6 only. Now, this is again that you have seen several times, even if you are not a cellular provider, it means access point name. And it's more or less the logical name referring to the GGSN. Okay, so it's the one that is at context, at TCP context activation, performing the DNS resolution to get to the GGSN. Okay? The DNS response contains the list of GGSN addresses to select for that user equipment, for that cellular phone. Now, what is important here when you deploy IPv6 in a cellular network? You could do this. You could have support for IPv4 v6, v6, v4, and so on. But what is being done by many cellular providers, in my opinion, is they are providing different APNs for different kind of services. Okay? While you could support dual stack and single stack in a single APN. To do that, what you do is support this RFC. RFC 7050 is allowing to discover the IPv6 prefix used for the IPv6 address synthesis. And that allows you to support all kind of devices which can be, as said before, dual stack, IPv6 only or IPv4 only. Okay? Basically, what you will get with that is you support all kind of devices. You make it easier because you are supporting what the device is asking for. Okay, you don't need to configure something different for different devices. Just you appear to the device as whatever the device needs. So you do a progressive deployment, and over the air, that's what it means. You can update the profile of the devices to get upgraded to more features. For example, a device that supports today only IPv4, maybe with an upgrade from the device vendor, Apple new release of iOS or new release of Android or whatever, it gets support for IPv6 and so on. So you get updating them as soon as you need them. Okay? I don't think, let me look for a minute something, because I'm not sure I have something in the slides. No, I don't have it, so I am going to explain it now. Okay. Today in cellular networks, there are basically two streams: Android, iPhone, right? That's it. All the rest is gone, almost. Well, Microsoft, for what it makes, Microsoft is reacting the same as Android. So we have in one group Apple, in another group Android and Windows. Windows Mobile, or whatever is the name they have right now, they have. Android has support for CLAT. So all they have explained now, it works perfectly with Android and Windows. Now, Apple took a different strategy. About 3 years ago, Apple announced that in 1 year from that moment, so 2 years ago, they will mandate that all applications they have need to support IPv6. Okay? And that actually happened, I think, about 1 year and a half, more or less. I think it was September 16, I think it was. I'm trying to remember by memory, but I'm not too much wrong. So what that means, if you have an an application in the App Store that is not supporting IPv6, you will sooner or later, and I have seen customers in that situation, receive a letter from Apple telling you have 15 days to update it. If you don't do that, we drop it. No chance to complain. You have got 1.5 years at least of announcement previous to doing that. Okay? What that means, all the applications in iPhone support IPv6, so it means they don't need the CLAT. And in fact, Apple don't support the CLAT in iOS. Now, Apple got a problem. If you want to support tethering for IPv4 only devices, that is not going to work because of IPv4 only. In addition to that, Apple already pushed 2 years ago, even before it was a standard, Happy Evolve version 2, which means that even if they don't have a CLAT, they have something equivalent, which is one in the, I believe is the name, which is doing the address synthesis inside the phone. So even if by chance there is an application that is using literals, or you browse for a literal website, it will work. Okay? Even if you have something. Okay? The problem is that if you are offering tethering, you need to have an APN which is providing a still dual stack for the tethering, which is bad for the cellular providers because they are forcing to have actually two APNs, or one APN providing context, one for the tethering and one for the rest. Okay? So the last time I talked with the people responsible of IPv6 in Apple, that was, let me think, I think it was November in Singapore, when we had the last idea. They said if the ISPs request to us to have CLAT, we will do it, but we need to have the push from the ISPs. We are not going to do it because we want to have a few important customers, or many small customers that we need CLAT for the tethering. As I said before, the code is like this size, so doing that is like 5 minutes. An Apple developer is probably more the testing process than actually implementing in the code something that is already correct. Okay? So that's the only inconvenient of using 464X-LAT, that you still have to keep a dual stack APN or PDP context for the tethering in Apple devices. But I think that's something that will be sorted out quite soon. And even if you have to supply that, that's cheaper than trying anything else, so never mind. Okay? I think I will put this in the slide for the next time because it's something very, very, very interesting for the people to know. Now, how the IPv6 addresses are allocated to the cellular networks, which again is similar to the broadband networks. The first one is in the cellular networks, each PDP context which IPv6 support get a /64. Okay? And that was introduced a long time ago. So this is not something new. This has been here since a lot of time. The XPv6 is not well supported in cellular devices. Okay, and Android is saying we will never support, and I know the person is saying that, and he's saying we will never support. And there is another big debate with this person because it's a religious thing that they want to support the XPv6. discussion, if you look for forums and so on, look for Lorenzo Peliti, and that's the person. It's easy. He will tell you, no, I am not going to support it, and he's the boss in the development in Android. And there is a specific not use. So a stateless address auto configuration, which is the standard thing, is the same if you have started already Slack. Stateless auto configuration in non-cellular networks is the same. So I am not going to explain it. The difference is which devices are in this case acting as for this as the router for this transaction. Okay? Tethering. What happens with the tethering is that this single /64 that the device will get will be switching the device to be, instead of a host, to be a host and a router. And then will provide IPv6 connectivity from the same /64 to the rest of the devices in the tethering. Okay, so that's the way it works. It gets /64 and shares that /64 so that the phone becomes not just a phone, but a phone and a router. Okay? For IPv4, basically it's doing an AND. For IPv6, it's just extending the prefix for the rest of the devices. As well as when we have native IPv4, is doing the tethering by means of an AND with private addresses. Exactly the same. Oops, that was reversed. It was the end instead of the beginning. The RFC that describes that. Okay? So which is not the case in cellular networks. If we were using DHCPv6 for those networks, how we are going with the time? We have up to 4 or 4:30? 4. Oh, so we are not going so good with the time. So if we have the DHCP, it will be the same as using DHCP in broadband networks. No difference again. Now, there is another document which is RFC 6603, which makes a lot of sense if you are using DHCP, and this is useful in broadband networks, which means basically, for example, if I allocate a /48 to every CPE, typically you will use also /64 for the point-to-point link, right? Everybody else that? And then the IP address for the CPE, right? Or the prefix for the CPE in IPv4. In IPv6 is the same. We have a point-to-point link, typically /64. Some people use /127, and then you have a prefix, the /48, for the point-to-point link, for the device. Okay? Well, there is a way, and it's becoming more and more common to use from the same /48 that you allocate to the CPE, the first /64 as the point-to-point link. So instead of using 2 entries in the DKIM router, you just use 1, which is fantastic because you save half of the DKIM. Okay? This is supported even using BGP or SPF, so even if it's not just a static route, it works also with routing protocols. And this was actually invented somehow for okay? I have also an IKEA document describing this because it's not very clear anywhere how to use that in the documents. It's just described as an option, but nobody explains in any document how to do that. So, if you have been doing all the steps from IPv4 to IPv6, I already mentioned, probably most of the traffic, at least half probably, of your network is going to YouTube, Google, Facebook, etc. Akamai, all the content delivery networks support today IPv6, so it means you can say, hey, most of my traffic is already going IPv6. Didn't notice that. That's the end goal. Customers don't need to do anything. Sometimes you need to replace or upgrade the CPE, but that can happen only for other reasons. Like you are providing more bandwidth, the old CPE don't work anymore, or you are moving customers from copper to fiber, or whatever. It's a bit old. It's from July, August, I think, August 2007. So it's 7 months old, 2017, sorry. This is the total cellular traffic going through IPv6 in all the 4 bigger cellular providers, while Sprint, and I am missing one. Verizon, exactly. So those 4 providers already surpassed 70%. Probably today is 80%. It's my guess. I can try to look for new data. Operation for many people. But if you look, for example, T-Mobile already reflects more than 90%. So a single provider already surpassing that. Okay, that's the average between the 4. Now, but also broadband networks. And my perspective is, if you have what I call a multi-service network, where you have a cellular part, but also corporate customers, residential customers, you can do all of them with a single transition mechanism. Okay? You just need to have the support in the CPEs. So make sure to push your CPE vendors or refresh them with Linux. That's it. It works. I have one here. This is a Chinese box, 5 gigabit ports, $10, 2 radios. I have used this for people connecting in a right section. $10 box. And I refresh it with whatever I need, and I configure it. For example, in my home, I have one of these instead of the one that provided by the SP. And it's doing Asterix with voice over IP, it's doing IPTV, it's doing IPv6, it's doing the NAT capability, because most of the time the problem is the capability for NAT, and I got 800 megabits of translation at maximum. My link is 50 megabit link, so I don't care. I have only 50 megabits. 800 capability instead of 1 gig is more than enough. Okay? So that go to OpenWRT, you will find your model and the instructions to download it, and that's it. So I have deployments in Latin America using not this box, but all kinds of boxes from different vendors, and we make scripts to refresh them remotely and keep them updated. Backups, which USB 3G sticks, using also 464X LAT, so it works. 10,000 customers is trial, but in 3 different ISPs, but it's not just a small group, right? It's a big trials. Of how you can do by your own this testing of CLAT. I have this implemented in virtual machines. So in this case, it was not a hands-on tutorial, but sometimes I do this hands-on, and the people can deploy the virtual machines to do all that. NAT64, DNS64, we use Bind, and then we have the CLAT in one of these CPEs or also in a virtual machine, and that's it. That's using documentation prefixes for both V4 and V6. And well, that's it. I think we did I am going to stay here for the break if you have additional questions anyway, and I will stay here also tomorrow. So questions? I want too fast, too slow, or right in time? No questions? So give you the Okay, so again, I have more probes. If somebody wants to collect them, I am going to stay here 10-15 minutes during the break. So no, we don't interrupt the next session. And that's it. If you have any questions, you have my and we are happy to provide training, consultancy on site, whatever you need, from A to Z. I don't think you are going to find so many people with so much experience. It's a fact. We started in '99. Okay. Thank you.
Where are you based?
Madrid. Wow. 3 months per week, planes.
Yeah.
per month, three